In this video, we're going to be talking about factoring special trinomials, and that doesn't mean that we're going to actually have to do anything differently than what we did in the previous videos when we were factoring trinomials, but it does mean that if we can recognize that this is a special trinomial, that we might be able to save ourselves a couple of minutes of work. So let's start with the example 4x squared plus 12x plus 9. Let's factor that the way we normally would. And I think in class you guys like the method where we multiplied the 4 times the 9 first. In this case we get 36. And then we want to write down a list of numbers that multiply to get 36. So 1 and 36. You can of course do -1 and -36. 2 and 18, 3 and 12, 4 and 9, and 6 and 6. I think those are all the numbers I can come up with. And you're looking for the two numbers that are going to add up to this middle term. In this case, 6 and 6. What we then did is we split up this middle term into two pieces. We wrote it as 4x squared plus 6x plus 6x plus 9. Then what we did in class is we factored by grouping. We grouped the first two terms and the last two terms together, and in each group we factor out what we can. So in the first group we can take out a 2x, that leaves us with 2x plus 3. In the second group we can factor out a 3, and that leaves us with a 2x plus 3. Now you'll notice there's a 2x plus 3 in each one of our two terms that are left. We can factor that out. And what are we left with? Well, we have a 2x in the first term and a plus 3 in the second term. So we're left with the 2x plus 3. And you'll notice that we have 2x plus 3 appearing twice, so we can just simply call this 2x plus 3 squared. Alright, so when we factored this trinomial, we ended up getting a perfect square. And because we got a perfect square, the original trinomial is called a perfect square trinomial. So that's one of our special trinomials. And the question we want to ask is, could we have recognized that this was going to be a perfect square trinomial right off the bat, instead of going through these steps? The answer is yes, but it's not the easiest thing to say in words. I'll try to say it in words now, and then we'll put up a little formula. But you'll notice that this first term is a perfect square. In other words, just the first term is what? 2x, the whole quantity, squared. You'll also notice that the last term is a perfect square. That's just 3 squared. Now, if we had thought that in our heads and we noticed that, then what we can do to check to make sure, to see if this is going to be a perfect square trinomial, is we could multiply the 2x times the 3. That's 6x. And if that appears twice, if that 6x appears doubled right here in the middle term, then we have ourselves a perfect square trinomial. So in this case, 2x times 3 is 6x. And if we multiplied that 6x by 2, if we doubled that 6x, we'd get 12x. And that's how we can recognize that this is a perfect square trinomial. Let's write down a formula. In general, if we have a perfect square trinomial, then it's going to be able to be factored into something like a plus b, the whole thing squared, where a and b can be anything. Now if we actually multiply that out, if we have a plus b times a plus b, if we FOIL the thing out, we get a squared, first two terms. Outer two terms give us plus ab. The inner two terms give us plus another ab. And the last two terms give us a b squared. Now you'll notice we have two like terms. Those two middle terms are like terms. So we can write a plus b squared. That's what we started with. We can write that as a squared plus 2ab plus b squared. Now whenever you have a perfect square trinomial, that's a formula that's true. If you're given a perfect square trinomial, it'll look like this. It can be written in this form, and we can factor it by writing it in this form over here. Let's take a look at one more example, and hopefully this will clear things up a little bit. Let's factor 4m squared plus 20mn plus 25n squared. So of course you would first look and say, is there anything I can take out of every single one of those three terms? And you can't. And then you might notice, hey, 4m squared, that's just 2m the whole thing squared. Then you might look at this and you might say, hey, 25n squared is 5n, the whole thing squared. So you might be thinking, hey, maybe this is a perfect square trinomial. Well, the way that you can check is you take the 2m times the 5n. That's going to be what? 10mn. And if this middle term is double that, which it is, then you have a perfect square trinomial. The way that we factor this perfect square trinomial, now that we know that that's what it is really simple. We take the thing in parentheses up here, add the thing in parentheses over here, and square the whole thing, and that should be right. Of course, you can always check it, because you can FOIL this thing out, check it to make sure you get the thing that's above, and you do. So we just saved ourselves a couple minutes of work just by recognizing that this was a perfect square trinomial. Okay, let's move on and let's talk about factoring a different type of special trinomial. Let's try to factor 4x squared minus 9. And you look at that and you might actually think to yourself, well, that's not even a trinomial. And you're right, but we could write it as a trinomial by writing 4x squared plus 0x minus 9. And those are the same thing. So now we can factor this using our normal techniques. The method I think you guys preferred in class was multiplying the 4 and the negative 9 together. That gives you a negative 36. Then you want to write down two numbers that multiply to get negative 36. So of course there's 1 and negative 36, and 36 and negative 1, and 2, and there's a lot of them, 2 and 18, 18 and negative 2, and eventually you'll get down and you'll write 6 and negative 6. The list does go on, but we'll just stop right there. And you look and you say, okay, what two numbers add up to the middle term, which is 0 in this case? Oh, it's 6 and negative 6. So what we do is we split up the middle term. It used to be a 0x, but now we're going to write it as a plus 6x minus 6x. Same rule as before, it's just a little trickier because we're talking about a 0 term. We group the first two terms together. 4x squared plus 6x, we get grouped together. You'll notice there's a negative in front of the third term, and whenever that's the case, we usually pull out a negative from both terms, and you get 6x plus 9. Now we factor what we can out of each group. In this first group, we can take a 2x out, and we're left with a 2x plus 3. And in the second group, it looks like we can factor out a 3, and we have a 2x plus 3 left. Okay, we have 2x plus 3 in each one of our sets of parentheses and each one of our two terms that remain. So we can factor that out of each term, and we're left with a 2x minus 3. Well, that's kind of neat. We ended up with the same terms, except one has a plus sign and one has a minus sign on it. And if you do this enough, you'll notice this always happens in a certain case. Up here, we have two things that are perfect squares. 4x squared is just 2x squared. 9 is just 3 squared. And we have a subtraction between the two of them. So we have two perfect squares subtracted. We call this a difference of squares. And whenever we notice we have a difference of squares, we can just take the 2x plus the 3 and the 2x minus the 3, and we already know that that's how the factoring is going to work. So again, let's write a formula about this. In general, if we had a factored form here, we had two terms, a plus b, and the same two terms subtracted, a minus b, and we tried to multiply it out, we'd have to FOIL. So you do the first two terms, you get a squared. You do the outer two terms, you get minus ab. You do the inner two terms, and you get plus ab. And the last two terms give you a minus b squared. You'll notice that the middle two terms are like terms, but they cancel each other out. One is plus and one is a minus. So that means if we rewrite the left-hand side, we cancel the two middle terms, we're going to get a squared minus b squared. And that is a formula that you're going to see in your book. This formula means that anytime you have two perfect squares subtracted, it's a difference of squares, you can always factor it to look like this right here, a plus b and a minus b. Let's do one more example. Hopefully that'll clear things up. Let's try to factor 25m squared minus 16n squared. And you look at that and you say, oh, well look, this first term is just 5m, the whole thing squared. This second term is just 4n, the whole thing squared, and they're subtracted. The subtraction is important. Since that's the case, we know that we have a difference of two squares, and we automatically know how we can factor this. We're going to factor it into two binomials. One of them is going to be 5m plus 4m, and the other is going to be 5m minus 4m. And again, if you're unsure about this, you can always check it by FOILing the thing out. You first, outer, inner, last, and you should get the binomial that you started with. And again, we could have done this using our traditional techniques, but this sure was a lot easier doing it this way, recognizing that it's a difference of squares and factoring it really simply with one step. Okay, so one more thing I want to say is don't forget that your first step should always be to see, can you take anything out of every single term before you get started? Don't forget about that, and let's do a video quiz. There it is. Factor those two polynomials. Good luck.